Hello my dear students, good morning to all of you. In today's session we are going to discuss about very important topics. So which are those? The first one is Townsend's criterion for breakdown mechanism in two electrode system, okay, and the second one is experimental determination of coefficients. So which are those coefficients? So the first one is Townsend's primary ionization coefficient, that is represented with the help of symbolically how it is going to be represented, that is alpha, and one more coefficient, that is nothing but the Townsend's secondary ionization coefficient, that is represented with the help of symbol, that is gamma, okay. So these two bits we are going to cover in today's session, okay. Okay, let us start with the first one, that is what? Townsend's criteria for breakdown, okay. See here, in the previous session we have already derived this equation, right? So the amount of current which is flowing between the electrodes, nothing but the amount of the current with due to this huge amount of the current only the breakdown mechanism takes place. So how the breakdown process will takes place? So the breakdown, it is nothing but the due to the flowing of the huge amount of the current between the two electrode system, the insulating media, it is going to be gets failed itself. Is it right? So how much amount of the current which is flowing between the electrodes, that will be calculated with the help of the Townsend's mechanism or the Townsend theory. Is it right? So how we can calculate the current now? I is equal to I naught exponential into the bracket of alpha into D divided by 1 minus gamma into the bracket of exponential of alpha into D minus 1 itself, where alpha is nothing but what it is? Townsend's first or primary ionization coefficient, and D is nothing but the distance between the two electrodes, and here gamma is there, right? So gamma is the Townsend's secondary ionization coefficient, that is due to what? Secondary electrons. Is it right? So this is what we have already derived in the previous session, right? I think this is all of you familiar with this one. So this equation will give the total average current in the gap. In the sense that just you can observe this diagram. So between these two electrodes there is a small distance, or we can call it as a air gap, it is there. Is it right? This gap, it is completely filled with the gaseous dielectric medium or the insulating medium itself. Is it right? So here this equation, by using this equation, it will give the total average current in the gap before the occurrence of a breakdown. Getting my point? Before failure of the insulating media between the electrodes, what is the average amount of the current between the gap? So that we can calculate with the help of this equation, okay. So now let us consider as the distance between the electrodes. Distance between electrode, how we have represented here with the help of the symbol, that is small d here. Suppose the distance between these two electrodes, if it is increased, then what will happen? So the denominator term, so the denominator of this equation, which is tends to 0 here. So if the distance it is increased, means here also the amount of the current also it is going to be increases, because directly proportionality it is there. Is it right? So here what will happen? If the distance between these two electrodes, if it is increased, means the denominator term which tends to 0. When it will tends to 0? Only when this distance it reaches the some critical distance, that is represented by ds. What we can say? Whenever the distance between the electrodes, if it is increased, means the denominator of this equation will tends to 0 only when the d distance will be equal to the critical distance. Getting my point? So how will write now? This denominator term it is going to be tends to 0 only when the condition is what? D is equal to ds. Getting? So here for a values of, let us consider the two cases now. For a values, suppose the distance, if it is less than the critical distance, then what will happen? Means the amount of the current which is flowing between these two electrodes, if it is approximately equal to I naught, it is nothing but the ionizing current here, initial amount of the current, that is I naught. Getting my point? First case what I had considered, if the distance, if it is lesser than the critical distance, means then current I is approximately equal to I naught. Okay. Suppose second case, for D is equal to ds. In that case what will happen? This current will be reaches infinity. Nothing but huge amount of the current will be flowing between these two electrodes. Due to this huge value of the current, the insulating media between this electrode, it is going to be gets breakdown, right? So the current will be limited. How that current it is going to be limited means by making use of the current limiting resistors. Okay. Getting my point? So there are two cases I had considered here. The first thing is, if the distance between the electrodes, if it is less than the critical distance, means in that case current is approximately equal to the initial amount of the current itself, that is I naught. So there is, in that case what will happen? There is no breakdown of the insulating media. Only when, if the distance D is equal to critical distance, that is ds. In that case what will happen? The amount of current will reaches to the infinity. Infinity in the sense that this is the huge value of the current, right? So due to this huge value of the current, the insulating media gets break here. Is it right? In order to avoid that one, we can adopt. So that huge amount of the current can be limited by adopting what here? So current limiting resistor, it is connected over here. Is it right? With the help of this resistor, we can limit the current which is flowing between these two electrodes. Getting my point? So this condition, it is going to be called it as what? Townsend's breakdown criterion. Getting? So that only we are studying now. Is it right? So that we can, how we can write it now? So this equation I can reframe it now. So gamma into the bracket of exponential of alpha into d minus 1. So this is equated to 0 is there? That I can take it to the RHS side, right? So if you take this to the RHS side, means it will be equal to 1 here. So call this equation as number 3. Okay. So okay, next here, normally when we compare here, so when we multiply inside this one, gamma exponential of alpha d minus gamma, this will be equal to 1, it is there. But comparatively, the value of the secondary ionization coefficient, that is gamma, which will be very small itself. That is why it is neglected. And what is remaining now? So this gamma exponential of alpha d equal to 1 itself. Normally exponential of alpha into d is very large compared to what it is? Secondary ionization coefficient, that is gamma. So just what I had written here, I had multiplied inside here gamma exponential of alpha into d minus gamma, this will be equal to 1, right? So this gamma value is very small compared to the what? Exponential of the alpha into d here. Getting my point? Nothing but what? Gamma is the Townsend secondary ionization coefficient, which is very small when we compared with the Townsend's primary ionization coefficient. That is why this term gamma, it is neglected. Then what is remaining now? Gamma exponential of alpha into d, this will be equal to 1 itself. So call this equation as number 4. Getting this one? This is the Townsend's criterion for breakdown mechanism in two electrode system. Okay. So next what I had written here. So for a given gap spacing, nothing but what it is? The distance between or the gap between these two electrodes. Here in between these two electrodes, gaseous medium will be present here. Is it right? So this gas pressure, it is also very important because the coefficients alpha and gamma, which are the functions of the gas pressure and the ratio of electrical field to the pressure itself. Is it right? So for a given spacing, nothing but a d, and at a given pressure, nothing but which pressure? That is gaseous media, gas pressure. So which insulating medias we can use it here? Air, it is the perfect insulator, or the oxygen is there, carbon dioxide, so nitrogen, sulfur hexafluoride. So these are what it is? So these are the gaseous dielectric mediums. Is it right? So this is the D and this is the gas pressure represented by P. So the value of the voltage for a given spacing D and the gas pressure is a P, and next when we are going to be apply the voltage, the value of applied voltage. So this voltage which gives the two coefficients, which are those, one it is alpha and gamma, by satisfying the breakdown criteria. So that voltage it is going to be called it as what? Spark breakdown voltage. Keep it in mind. What is the definition of spark breakdown voltage? So the given spacing at the given conditions, what are those? The distance will be given and the gas pressure we will be knowing, and we are going to be applying voltage between these two electrodes, and now using these three factors we are going to be determine the coefficients, like which are those? One it is Townsend's first ionization coefficient, and this is the Townsend's secondary ionization coefficient. Getting my point? So this voltage it is going to be called it as what? Spark breakdown voltage. Getting? And the corresponding voltage is going to be and the corresponding, make it this one as a distance, keep it in mind, not a voltage. The corresponding distance is going to be called it as a sparking distance, represented by how it is? ds itself. Getting this one? So here also representation it is there, nothing but sparking distance it is. I hope this is clear to all of you. Townsend's criterion for breakdown it is. Okay. Next, what is the one more bit of this? Experimental determination of coefficients. Which are those coefficients? One it is alpha and one more is gamma. Correct? So for this one, how we will determine the alpha and gamma? So this is the experimental arrangement for the determination of the alpha as well as the gamma coefficient. What it consists of? First thing here. So basically we have considered the two electrode system here. The two electrode system consists of the uniform field electrodes. Which are those electrodes? One it is anode and one more is the cathode. Is it right? So we can call it as those two electrodes. One is considered as a high voltage electrode, another one is considered as the low voltage electrode. So keep it in mind. For the determination of the coefficients like alpha and gamma, we have considered the two electrode system. It consists of two electrodes, which are those? One it is high voltage electrode and one more is the low voltage electrode. Getting my point? So next thing here. The first thing here, high voltage electrode. So this is the electrode system. This is high voltage electrode and this is the low voltage electrode it is. Getting my point? So this high voltage electrode, it is connected to the DC power supply. Getting my point? So high voltage electrode, it is connected to the DC power supply through the protective resistance here. Next, this is low voltage electrode. Second one is low voltage electrode. So this low voltage electrode, it is divided into two types. So what are those means? The first one is it is divided into two electrodes. Getting my point? Central electrode and one more is guard electrode. Keep it in mind. There are two electrodes are there. One it is HV electrode and one more is the LV electrode. HV electrode, it is directly connected to the DC power supply through the protective resistance here. And below, which one is there? Low voltage electrode. This low voltage electrode, which comprises of again two electrodes are there. One it is central electrode, one more is guard electrode. Keep it in mind. Okay. So now this central electrode, where it is connected? Observe this diagram here. This central electrode which is connected to the ground here. Getting my point? The central electrode which is connected to the ground through what? Electrometer amplifier. Getting my point? Amplifier means it will boost of the signal strength here. Is it right? So this central electrode which is connected to the ground through the electrometer amplifier, and this electrometer amplifier will be having the resistance of how much? That is of order 10 raised to 9 to 10 raised to 13 ohms. Getting my point? So one more electrode, which one is there? So that is guard electrode. Guard electrode, where it is connected? So this is the guard electrode directly connected to the earth itself. Getting my point? So this is all about the two electrode system. So next, what it is there? The electrode system, this electrode system, it is completely evacuated or completely placed in an ionization chamber. So what I am telling here, this electrode system which is placed in the ionization chamber, which is this ionization chamber which is either made up of the metal or the glass itself. Getting my point? So next thing here, this chamber is completely filled with the vacuum as well as the desired gas pressure. Getting my point? So now I told that there are two electrodes, one it is anode or cathode, nothing but high voltage electrode and the low voltage electrode. So now the cathode, it is going to be irradiated using an UV lamp which is kept outside the chamber itself. So among these two electrodes, one it is the cathode is there, one is the anode is there, is it right? So this cathode we have observed in the diagram also, is it right? So here this cathode, it is irradiated nothing but the exposed to the radiation, nothing but which radiation we are passing here, that is ultraviolet radiation which is of a sufficient frequency. Getting my point? So this light energy we are passing or we are irradiating on the which electrode? Cathode, is it right? So how we are passing? Just by placing these two electrode will be completely evacuated with the ionization chamber. This ionization chamber, it is made up of a metal or the glass itself. Inside this chamber, this will be completely filled with the vacuum as well as the desired gas pressure. Next, what I told here, the cathode is irradiated or exposed to the radiation of ultraviolet. Getting my point? So this light energy we can use for the emission of electrons from the cathode. Getting my point? The UV radiation produces the electron by which process? Photo emission process. Getting? So this is all about what it is. So this is all about this diagram. Okay. This is the experimental arrangement. So now let me consider two cases. Okay. In the first case, when DC voltage is applied. Okay. Here what voltage we are applying? DC power supply we are providing here. Suppose the first case is when the applied voltage is low. In that case what will happen? In the applied voltage, if it is low, means the current pulses starts appearing. So these are the current pulses starts appearing. When it is applied voltage is of a DC type, the first case is when the voltage is low, then the current pulses are going to be starts appearing. So these are the current pulses. So how the current pulses are going to be appearing? Due to only the positive ion impact as well as the electrons flow itself. Getting my point? So the current pulses starts appearing due to the electrons as well as the positive ions. So these current pulses are going to be recorded with the help of the cathode ray oscilloscope, that is CRO. Getting? So next thing here. So this representation when we got, when secondary electrons are produced by the positive ions itself. Getting my point? The first case what we had considered, applied voltage is low, means the current pulses are going to be starts appearing. Is it right? So the pulses starts appearing due to the reason of the secondary electrons which are produced by the positive ions itself. And these current pulses are going to be recorded with the help of a instrument that is going to be called it as a CRO, cathode ray oscilloscope. Okay. So this one, when the secondary electrons are produced by the photons. Photon means it is the light energy. Which light we are passing on the cathode? That is ultraviolet radiation of a suitable frequency. If it is irradiated or exposed to the cathode, means secondary electrons are going to be releases. So in that case, how the current pulses will be there means that we have represented here, and we can record with the help of the CRO. Getting? So this is nothing but the first case what we had considered. Okay, let us move on. Okay. First one we have discussed about the first case, is it right? When the applied voltage is DC and suppose when the voltage is low means the current pulses are going to be starts appearing due to the electrons as well as the positive ions, and these current pulses are going to be recorded with the help of the CRO, right? Okay, let us move on to case 2. When the applied voltage, so first case what I had considered, applied voltage is low. In the second case what I am considering now, when the applied voltage is increased, then what will happen? Due to this increased or the high voltage, the current pulse starts disappearing. So getting my point? So next, this process what we have represented here, this is nothing but the current growth curve in the Townsend's discharge. Okay. As we already know that the breakdown mechanism, nothing but the insulating media present between the two electrodes gets a breakdown due to the flowing of the huge amount of the current, is it right? So whatever the breakdown, during the breakdown a strong conducting spark it is going to be produces, right? That spark it is nothing but the electrical discharge. So the electrical discharges are of two types are there. Which are those two types? Already discussed in the first session, right? So first one is self-sustaining discharge and the second one is non-self-sustaining discharge. Nothing but what it is. Self-sustaining discharge means that spark can be monitored, can be controlled. The strong conducting spark can be self-sustained, nothing but the self-monitored or self-controlled. How? When it is going to be controlled? Whenever the gas pressure, if it equals to the atmospheric pressure, means what will happen? The spark it is going to be gets monitored or controlled. So that is going to be call it as what? Self-sustaining discharge. And this is all about second one is non-self-sustaining discharge. So this this is nothing but the spark it is not going to be controllable. Getting my point? So this curve, it is nothing but the current growth curve in a Townsend's discharge. So there are three reasons are there, just you observe it here. So in the initial portion, so that is represented by T0, and the second portion, middle portion is T1, and this is the third portion, T2 is there. Okay. In the initial portion, current, so this is the current is there in the x-axis, voltage, and this will be the current here. This is nothing but the voltage current characteristics. Okay. So in the initial portion T0, the current it is going to be increases slowly. We can observe the curve here. The current I increases slowly, but it is in nature of a unsteady manner. Okay. Whenever in the T0 portion, current it is going to be increases slowly but unsteadily. Okay. In the regions of T1 and T2 here, the current I it is going to be increases steadily due to the Townsend's mechanism. And beyond this T2, the current what will happen? The current rises sharply and breakdown occurs. Is it right? So that current will be given by how? I is equal to I naught exponential of alpha into D here. Getting my point? Beyond the T2, if current it is going to be increases sharply, means that results into a breakdown of insulating media between the two electrodes, right? So now for determining these two coefficients, alpha and gamma, alpha it is nothing but the primary ionization coefficient, gamma is the Townsend's secondary ionization coefficient. Okay. So in order to determine these two coefficients, means what we have to consider? The voltage current characteristics. For what condition? For the different gap settings, nothing but the distance between the electrodes, we can vary it and we can calculate the alpha as well as the gamma. Different gap settings under constant electric field. This is very important. How will determine these two coefficients? By considering the voltage current characteristics, by taking the different gap settings, nothing but the distances we are going to take under the electric field of what? Constant applied electric field, that is E. Okay. So this is the graph, this is the curve. So different distances we have taken here, D1s, D2s, D3s, three different settings of a gap I had taken here. D1 S, it is nothing, S stands for what? Sparking distance, keep it in mind. sparking distance 1, sparking distance 2 and sparking distance 3 here. So different gap settings we have taken, but the applied electric field will be same here. Is it right? So these are the representation of applied electric field E1, E2, E3. Getting my point? The slope of all the curves gives the alpha. Getting my point? The slope of the curves which gives the coefficient what? Alpha. Alpha, it is the Townsend's first ionization coefficient. If you know the alpha means we can calculate the gamma, right? How we will calculate the gamma? By using the equation, which one? So where is that equation is there? So the using, if you know the alpha means, if you know the amount of the current, initial amount of the current means, we can calculate easily this Townsend's secondary ionization coefficient, that is gamma, we can calculate with the help of this equation. If we know the distance, if you know the alpha value where we'll get? From the slope of that curve. Is it right? Alpha we will be knowing, and different gap settings they will be given, and we will be knowing the applied electric field, and initial amount of the current we will be knowing. And if you know all these factors means we can calculate the gamma, right? Easily we can calculate the Townsend's secondary ionization coefficient. So this is all about experimental determination of the coefficients, like which are those? One is alpha and the gamma. Getting? So this is all about, very important topic it is from the exam point of view. Just to concentrate towards this one. Okay, I hope this is clear to all of you. Okay, thank you.